This project is for CSCE522 with Dr. Farkas. My name is Nate Fuller, and my partners are Daniel Bauer, Bill Brower, and Sabrina Wilkes-Morris. Our credentials are as follows. For myself, I have taken a summer cyber education course at the Air Force Institute of Technology in Ohio, where we learned about computer and digital forensics and how to investigate computer crime and gather evidence. Daniel Bauer has had algorithmic design courses that have benefited him in his understanding of intrusion detection algorithms. Sabrina Wilkes-Morris is an intrusion detection analyst responsible for managing intrusion detection devices, and Bill Brower has taken algorithmic design and discrete mathematics courses. Our project is on computer forensics with a specific focus of intrusion detection. In this video, I will talk more about intrusion detection systems, specifically their problems and recent solutions to help minimize the problem. The importance of our problem is that intrusion detection systems generate anywhere between a couple hundred and a couple million alerts per day. It is difficult, if not impossible, for operators to cope with that kind of load, so attacks slip through the cracks, and intrusion detection systems aren't as effective as they could be. A big problem in intrusion detection is dealing with the sheer number of false alarms that get generated on a daily basis. It's difficult to separate real attacks from false positives because any number of things can confuse IDS systems. For example, inconsistencies like sensors made by different manufacturers, software tools that aren't optimized for the use case they're being utilized in, corrupt DNS data presenting network noise, and software bugs can all increase the number of false alarms and IDS generates significantly. The two main types of intrusion detection systems in use today are rule-based and anomaly detection-based. The three challenging aspects of our proposed solutions are picking techniques that would work well together based on the available data and sensors, integrating multiple techniques in an effective way, and balancing computational effort and the resulting reduction in false alerts. Unfortunately, both types of intrusion detection systems are prone to alert flooding. Depending on the size and exposure of the network, intrusion detection systems can generate anywhere between several thousand and several million alerts a day, and human operators have difficulties coping with that kind of load. One way of easing that burden for operators is to integrate an aggregation and correlation component to aggregate alerts and condense data so operators have less to look at. Testing has been done with current technologies such as Internet Security Systems, Real Secure Network Engine, Cisco Systems Secure IDS, Web IDS, TCP wrappers, and other IDS systems to identify approaches that successfully separate false alarms from real attacks, and intrusion detection systems with a capable aggregation and correlation component consistently generating false alarms. The main solutions that we have to our challenging aspects and challenging problems are computational immune systems, Markov chains, and Bayesian networks. Lastly, I would like to point out the contributions of our team. I decided to voice over the video as well as make some final touches to the PowerPoint and editing notes, while Sabrina, Bill, and Daniel put together the meat of this presentation and laced it with the important details of our project. It is truly an honor to work with them, and I look forward to working with them to finalize our project and technical paper.